Okay, welcome back everyone. Hope you had a good lunch. So let's get stuck back in. Let's have a look at the challenge we started just before the lunch. So the idea was to now merge these two full data frames, one from surveys and the species. So the question would be, what do we do? Do we do a left merge or right merge or inner join? Well, I would argue we do a left merge because if there are any field recordings for which there is a species ID that we don't have further species ID information on in the species file, we probably still want to keep that data. And if we choose to plot nans somehow, which isn't done by default, then we could in principle to plot or just anyway discover where there are in fact recordings where we don't have species information in the file. So we probably want to do a left merge. So let me just check. So we've got the surveys, df, that's the full surveys. Species df, I've also got loaded. So then I can do a merge, saying, I'll call it, what should I call it? I'll just call it merge data frame equals pd.concat. And the left one will be the survey df, and the right one will be the species data frame. I'm not going to specify the join key because Pandas can figure out that it's species ID. I'm not going to specify, I will specify how, because I'm asking for a left merge rather than default inner. So yes, that should give me the merged data frame. Oh, surveys df, not survey. Yes, because I have forgotten that. Sorry, I'm okay. I'm thinking concat. No, not concat. Merge. We're not doing a concat. We're doing a merge. Sorry about that. The clue is in the name, merged. So right, so that should be our merged data. Out of interest, we can actually check. So we can see, for example, that there is an entry here where we can see for the taxa. So also for in this challenge, we want to plot the taxa. We can see an entry here where the taxa is an N. So then you might think, oh, hang on a second, why is that? Is that because we are somehow lacking information about that species ID in the species file, and therefore it couldn't identify, it didn't have a genus or species or taxa to look up? Well, possibly. However, if we look at the that entry, let's see, 35547. This was the right one. And we look at what is the, oh, I've got all the information here right in front of us actually. So, well, actually, we can see that the issue was not, the issue was not that there was no genus, species, and taxa information in the species file. It was actually that for that recording, the species ID itself was missing in the original file. So no wonder that there's no genus information, etc. Because how could there be? There's no join key. So Pandas has had to just simply say that that is missing as well, that those are nans. That raises the broader question of, is there anywhere in the file where nonetheless it might be the case that we have some missing genus and taxa information because that was missing in the lookup file? Well, we can ask that question by saying, are there any cases where sorry, are there any cases where the taxa, for example, because that's what we're going to plot, where that is not a number, where that is a nan? So I'm asking the question, is nan dot taxa? And remember, we can use the syntax with square brackets taxa for a data frames field, or we can use .taxa, which is an attribute. Both are valid. I use .taxa, why not? We're asking, is that, basically give me the entries within my merged data frame where, and I'm going to do selection criterion. I'm going to say where it's the case that the taxa is a nan, and it's not the case that that is due to the species ID being a nan. In other words, I'm trying to say, well, apart from the cases like the one I just found at the end where the species ID was a nan, and that's why there's no taxa information, is there ever no taxa information whereas there is genuine species ID? So give me all the entries in the merged data frame where that might be the case. Forgot to add _df to my name here. So the data frame with all those results where that is the case, that is returned, is empty. In other words, that is never the case. So therefore, we can conclude after doing this check that the species data frame, and in fact, therefore the species CSV file, must have contained lookup data for all the species IDs that are genuine values, i.e. not nans, in the surveys file. Okay. So now we've got our merged data frame. So how can we plot that? Well, the question is a little bit vague. It says plot the distribution, calculate and plot the distribution of taxa by plot. That could be interpreted in different ways. Let's just take the simplest interpretation, which is that what we care about is maybe the number of different taxa that show up in the in the survey results for a given site. So to do that, we would like to say, well, for the we want to plot that for calculate and plot that based on what the plot ID is, i.e. what the site is. So we're going to group our data frame based on the plot ID, and that is not square brackets, but it's a method. And then what is the metric we care about? Well, we care about the taxa. I'm going to do dot taxa, or I could do square brackets, colon, quotation taxa. We care about the taxa. And what do we care about? Do we care about the mean value of the taxa? Do we care about, what do we care about concerning the taxa? Well, we care about the number of the unique taxa that there are for a given plot ID. And if you recall from yesterday, there is actually a nice method that we can call on a series, on a Pandas series, which is the n-unique method. We did use 2 steps ourselves to calculate the number of unique values within this field or within any given field, but you can simply use the method n-unique to directly give you the number of unique values of that field. So let's see what that gives us. Right, so that gives us, for all the different plot IDs, 1 through 24, it gives us indeed the number of unique taxa. If we just look at before doing that, okay, it's not very easy to look at. Well, the description will be very useful because it's not meaningful for non-numerical data. Okay, so fine. So can we plot that? Yes, we can. So I haven't given this a name. Let's call this n unique taxa per site. Setting we just computed. And then I'm going to say plot that as a bar plot. And it shows us some, not particularly interesting, but it shows us that, yeah, shows us the number of taxa, the number of unique taxa that are present in the data for these different sites. Okay, so that's the first bit. Second bit, Oh, well, actually, there's an alternative interpretation that we can take of the first question, which is that rather than asking for the number of unique taxa, we could say like how, because that doesn't give us any insight into how common a given taxa is at a given site, right? It just tells us whether it occurs at all, or how many different unique taxa occur at all, no matter whether it's one sample or a gazillion samples. So the other question, the way to interpret this question might be to ask, how many occurrences are there of a given taxa per site? And then what we could do is, if we want a similar plot and the x-axis have the different sites, we could have maybe a stacked bar graph where the stack reflects, the different parts of the stack reflect the different taxa and their relative prevalence, or well, absolute numbers encountered for each taxa is the size of the bar. So how would we do that? Well, we could think about now we're going to count stuff. We're going to work with the same. We're going to again group things by. We're going to group things again by the plot ID as before, but now rather than getting out simply the taxa themselves and then getting the number of unique taxa, we are actually again going to group things group by taxa, and the result we're ultimately after is the number of occurrences of a given taxa once it's grouped by once it's grouped by plot ID as well. So we know we can do a count to get the number of genuine non-nan values for a given field. But what field are we going to use for that? Well, remember, we can always use record ID, because no matter whether, for example, the weight wasn't recorded in some cases, for every observation that exists, there is a record ID. So if we count the record ID, we'll be good. So we'll choose a record ID as a thing to count over for each plot ID and taxa, and we'll do the count. So this will give us an overview that for each plot ID, for the different taxa that are found, what is the how many occurrences are there? Then so we would like to plot that. Let's call this something site taxa counts. And can we simply plot that? By now you might have already probably looked at the data and immediately say, well, I'm going to have to do something additional to plot that in a way that I want, because if you do that, visually it's not great because of the oh, and I haven't stacked it either. So even if we do stack it, even if I do stack it, it's not very informative because, well, it doesn't actually even work given the format it's in. As you can see, there's little bars next to it. So we want to unstack the, you can see the how this is nested here. So basically what we want the thing we ask Pandas to plot should be a data frame where we have different series for the tax. Well, let's just say, so if we unstack this site taxa counts. Right, so basically what we have is we have a distinct Pandas series for each different taxa with the count for that taxa and the plot ID. That should allow us to create a stacked plot. Okay, so that's what that looks like. It looks as if, I'll make it a bit bigger because it might be quite small depending on your screen. Difficult to spot. In fact, I'll make it full screen. So it looks as if the rodents are completely dominating each site, and yeah, so you can see there are the other taxa are present. There are some birds and a few of the taxa, but the rodents are completely dominant. So yeah, tells you that. Anybody's any other better solution or better or different approach or any questions about that? Yeah, feel free to put it in the chat or ask. The rodents are playing. Yeah, I don't know what the geographical sites were of these, but or how the fieldwork was conducted, but yes. Okay, so So yeah, the solution, the second part we didn't look at, bisects by plot. Well, that's just further, you can have a look yourself, I would say. It's probably worth us moving on, but there's just more you can do. There's a pivot table that they introduce, and if you're interested in that, you can look at the documentation for that and how that's done. So to produce this stack plot. As I said before lunch, I don't suggest we look at this biodiversity index calculation, because although it will give you more practice, I don't think it really conceptually necessarily adds anything. It's worth us spending the remaining time that we have on the remaining lesson materials. So this episode has been about combining data frames in different ways, and then doing some more plotting based on the combinations. Next up, we'll do a little bit on workflows, automation, some of which we covered already. So I'm not going to spend a lot of time on this section, and I don't suggest that we spend a lot of time doing actually working through the challenges. Instead, I'll try to talk through and clarify any points. So I would encourage you to definitely ask, as I'm going through this, ask if anything's unclear, and to explain, because it's essentially not about this. Yeah, this is basically about generically about Python and about functions, creating functions. Because if we're talking about workflows and automation, what you typically want to do is you want to create some script that does a certain thing you do a lot in an automated way. So you typically want to build up a small code base to do stuff with. That typically involves, or should involve, defining some small standalone or small or large standalone functions which you can call from within your script, or interactively indeed, to automate what you're trying to accomplish. So this lesson, and it's worth probably looking back at it maybe in some detail later, if you come back to automating things, how to define how to work with Python. So for loops, we did yesterday. This example, we did something very similar yesterday. We had a for loop. So we had a list. We created a list, and I think if I recall correctly, we iterated over that list, because I told you that lists are iterable things. They're things that Python can iterate over in the following way, with a for loop that says for element, whatever you want to call it, in the iterable thing, then colon, and then the next line or number of lines indented do stuff which probably involves that element in question. So if you, for example, if you print it, it will loop through the elements in this list and print each one. Yeah, this pass is not really relevant. So this pass is here because in this case, we're not doing anything, but if you don't put any code at all, Python will complain that it expects an indented code. So if you don't put anything there, it'll complain. That's why pass is there. So this challenge loops here says, what happens if we don't include the pass statement? Python will complain because Python expects that that a for loop, whatever follows the declaration of a for loop, should be indented code. And if you don't provide any code at all, it will complain. So as we write the loop so that animals are separated by commas, in other words, that the output to screen of the animal names are not one on each on a separate line like that, but it simply ends up in a single line that has all the elements of that list, all the animals listed in a list with commas separating them. So one way you can do that is to combine. So if we have a quick look at possible solutions, is that one way to do it is to, for each time you go around the loop, print out the name of the animal, and then add a print, concatenate that element, which is a string, because animals is a list of strings. Add to that, I concatenate with another string, which is composed simply of a comma and a space. And this additional, so this comma and equals is an input option for the print statement, which simply says, don't print a new line, i.e. don't progress to the next line after you've printed. Stay on the same line so that next time you call print, it will print to the same line. That will print out this. One issue there is that, there's no space here actually, so there's no spaces separating it. And then there's this additional comma at the end, which you can tackle in various ways. There's a join command which you can use to actually so join is a method that will work on a string to join a string with other strings. And you can also approach, there's various solutions for this. So yeah, you can come across and solve this if you work out your own code. So when it comes to automating data processing, I mentioned already that when we are writing scripts to check, for example, to create files, check for the presence of files, we shouldn't use these IPython magical commands that are like shell commands, like simply typing ls, simply typing pwd, simply typing make dir, which you can do. You can type make directory, make dir within IPython, and it will work. That creates a directory called test. But the right way to do this within Python and in a Python script is to import the OS package for OS as operating system, and to use methods that sound a bit like the shell commands, like os.makedir, etc., os.listdir, things like that. os.changedir, chdir was one that Evgeny mentioned yesterday, to change directory to different directory within your Python script. So as you can see, os.listdir prints the output. So the rest of this is basically, I mean, this is working through an example where you might like to, so we have our surveys data frame, which has all the data for all the different years. Let's suppose, say, that you want to automate a workflow where you ingest such a data frame, but then you output the cleaned up data for each year in a different file. So what you would do then is, to do that, you would first of all create a data frame for each year extracted, the data for a given year extracted from the service data frame with selection criteria that we covered yesterday how to do, and then you use the toCSV method to write that particular data frame to file. And then the question is simply, how do you go about automating that? Well, you'd want to do some kind of, first of all, you'd want to do a loop over all the years within the data frame, within the original data frame. So you could see how many unique years there are within the service data frame using syntax that you've already come across so far. So that gives us a NumPy array of distinct unique years, which I think happen to be ordered simply because their occurrence of these years within the original data frame also happens to be ordered, which is something to watch out for. Don't make too many assumptions later on. And then you can create a for loop which iterates over that array of unique years, and for each year, which what kind of a type of an object will year be? Well, if we're iterating over this loop, if we're iterating over this object, this is an array, that's a NumPy array. The data type of it is int, is integer. So each of the years will be an integer. So so each year here will be an integer. So we're iterating. We're saying if we, what do we want to do? We want to create the file, define the file. We can define the file name where we want to store the data frame as follows by concatenating the path that is the same for all files with the unique identifier of the year, and then followed by the suffix or the extension. Now, ultimately, what do we want to get to? We want to get to a situation where we're doing a loop where we iterate over all those years, and for each year, we extract the data for that year from the data frame, then define the file name, then write the data frame for that year to file. And this goes around basically improving that and automating that. So there, so one way, so for example, we can clean the data by for each year adding the .drop NA to say drop nans, get rid of any entries where there's nans anywhere. You can iterate over if you only want to pick specific years, if you want to have some logic, and rather than selecting every single year, the question asks, let's say you want to generate a data file only for every 5th year. So when you iterate over the years that you found by listing unique years, you don't want to do it for every year. You want to do it for every 5. You want to skip 5, and then do that. How do you do that? Well, there's a bit here which there's some syntax that's useful to know, which Python syntax called range. Range is a built-in method. It will produce, so for example, if you type range some number 4, it's something you can iterate over for element, or I'll say for number, I'll just say n, in range 4, print n, simply as a sequence. So that is like our, so it provides an iteration variable. And what you can do is you can give that a couple of, you can give it a starting value and an end value. And if you do that, say 1 through 10, and we give you entries. I guess stops 1 before. So if you want to include 10, then you're going to have to go up to 11 rather than up to including 11. And what you can provide is an additional argument, which is saying how many steps to skip. So then in that case, we'll just do every 5 steps. So that's the kind of logic you can build in. And then once you've written that loop, to do that for every 5th year or for every year, what do you want to do then? You want to define a function. And I already showed earlier how to define a function. You say use the def keyword, then you say the name of the function, however you want to call it in future. Then you specify the any input arguments that it takes. Not all functions need to take input arguments, but often you do want to use something. You do something like yesterday we had showed an example where you add 2 input arguments, which could be numbers, but could also be strings. And we saw what happens if you input a string. And typically your function will return something. So once this code has been written and defined, and the interpreter has absorbed this definition, so in your Jupyter notebook by executing it, or within your Python script, making sure that this definition of the function occurs earlier in your Python script than wherever you're trying to use it, wherever you're trying to call that function. Then if you call that function, it'll produce, it'll spit out, in this case, the product. So I'll say 2 things. It'll print out the following line here, and also it will, so we defined this function to return something, and whatever it returns, if when we call that function, we have it as part of a statement where we assign the result arising from the right-hand side into a variable on the left-hand side, that means that that thing that's returned won't be output to screen. It will be absorbed into this variable that we've assigned it to. And if we then print out the value of that variable, then we get the answer there. So there's various exercises here to see what happens if you looking at scope of variables. So for example, if you have, let's say if you have, so the variable, let's see. The example that's useful to show. Yeah, here we go. So suppose you have a function definition. This is the function name. Okay, so suppose you have this function definition here, and within that function definition, you internally declare a variable called shared variable name, and you give it some value. However, it happens to be that outside of that function definition, you also have already declared a variable called the exact same thing, but you've given it a different value. The question is, what value is recognized where? So if you call that function, so if you now execute the following code after defining that function, namely print what value that variable has, then call that function, and then see what that value that variable has, the result is as follows. For the first print statement, it says it gives you the value that you assigned it outside the function definition. Then when you call the function, it simply prints out nothing to do with shared variable name. And after you call the function, if you again print shared variable name, it looks like the same value, that was printed the first time around, i.e. the same value that it was set outside of the function definition. And this is kind of a roundabout way of just proving and demonstrating that if you have a variable name that's called the same within a function, you declare it within a function as, sorry, I should say define it within it, give it a value within a function, as well as giving a value outside of the function. These two are actually so distinct in the following sense. This shared variable is actually not properly shared. It's called shared because, well, we called it shared, but actually these are treated differently. These are not assigned to the same bit of memory space. So this variable is only, the scope of it is local. That is to say, it's only recognized locally within the function, and its value set to without you is only true within the scope of this function. So if we were to do print shared variable name within this function, it would print out without you. But so the local scope overrides the global scope. But if we, but setting the value here does not in any way affect this global shared variable name. So this is simply something to be aware of when you're writing Python code, in case you ever do use or encounter somebody having written code that uses the same variable name in two different cases. Okay, so yeah, the rest of this is it's worth maybe looking at this. We'll go through this a little bit quickly and not looking at all the detail, because really this is all about gradually appreciating how you can build up a function to take input arguments and then gradually making this loop over all the years in your data frame more and more automated. So starting off by, so we define this function which is going to write all our CSV files. And to begin with, we say that there are explicit input arguments that you need to give, like which year to start writing, which year to end writing, and then passing it the reference to the data frame that you wanted to write from as well. But and then it goes through some looking at default arguments. So for example, if you have a function definition, and we've seen this when we looked at the help in Python for various methods and functions, we saw that when there were in the listing of the input arguments to a method, we saw sort of input argument and then equals some value, and that equals thing is the default value. Namely, if you call that function and you don't specify that input argument, then it will take a default value that's been defined in the function definition. So in other words, what that means is that when it comes to functions, there are mandatory arguments and there are optional arguments. Optional arguments are arguments that already have a default defined. So if you don't specify that argument when you don't specify a value for that argument when you call the function, that's fine, because Python knows to use a default value and it will just use that. Mandatory arguments, however, will be arguments where there's no default defined and you need to pass at least one. Now the question comes is when you specify, so if your intention, so possible confusion is if your intention is to use this function and to use it, so you call it and then you say, okay, I'm going to give it the name of my data frame, like surveys_df as the thing that contains all the data, then you know what? I know that it has a default definition of start year, so I'm not going to specify the start year. I'm just going to specify the end year. So you would call this function with two arguments. Let's see if there's an example there. Yeah, so suppose you were to call this function with two arguments, one being the name of the data frame, the other one being what you intend to be the end year, the final year to plot the data for. Now, given the ordering of these variables, the way that Python will interpret that, if you simply give it a number, it will take that second input argument that it receives. It will think that it will take that to be whatever is a second input argument in the definition, even though it has an option specified. It will think that you're providing an explicit argument for the start year rather than your intention, which is to provide it for the end year. So it is good practice when calling functions in Python that have default values set, for which any of the input arguments have default values set, but you want to be explicit to set some value to not do the default, rather than just calling it and giving it an input argument like the name of the data frame and simply writing 1977. It would be good to call it and say start year equals 1977 and end year equals whatever you want it to be. For any ones that are not the default. If you just simply want the start year to be 1977, you don't need to specify that, right? Because that is the default. But it's good practice then to actually use the name of the argument and to say name equals that value, because then you're sure that the function isn't misinterpreting what you're giving it as being specifying the value of an optional argument that was maybe preceding the one you care to give it in the function definition. So if that is all a little bit vague right now and not concrete enough, then I would encourage you to have a look again at this part of the lesson, of the episode, and maybe work through some of the examples in your own time. But I thought it worth going through this relatively quickly and sort of sketching out the main concepts, so we have some time left to try some plotting. So as well as defining functions, doing for loops, conditional statements, ifs are, of course, obviously useful in all programming. And this takes you through some examples about how to use conditional statements productively to streamline your decision-making process in your automated workflow. So to deal with cases where since you're not doing anything interactively, you need your workflow, your Python script to be flexible enough to deal with situations where a directory that you care about doesn't yet exist or anything like that. So you need to have conditionals in place, or it's good to putting conditionals in place to check all kinds of situations and to deal with different situations that might arise when you or somebody else uses your workflow. So the take-home lesson from this is just kind of generic, slightly even generic to programming, not to do with Python specifically. It's that it's good to break up what you're trying to do in small reproducible chunks, typically defined as functions. Then ideally even to have those functions take input and outputs and produce outputs which you can test so that you can check that they're working as you expect. To use loops efficiently, to use conditionals to deal with situations that might arise. And we haven't even talked about error handling. So there's a reference here somewhere to the fact that you can use a try statement. Try is a reserved keyword. So you can try to catch errors, all kinds of errors that might occur. So these kind of generic points about programming. So if you're not too familiar with Python yet and you'd like to have some practice, I'd say go back to this lesson in your own time and maybe have a look at that. So I suggest we finally get onto some plotting. So go to this lesson, next one, which is on using Plot9. So Plot9 is a plotting package, and it's inspired apparently by ggplot2. I'm not, I have to say, familiar with R really, or with plotting in R. But if you are, then I understand that this is should be quite familiar and natural. Conversely, if you're used to MATLAB and plotting in MATLAB, matplotlib's graphics plotting and plotting package for Python might be more familiar. So do Plot9 first, and then the next lesson talks about matplotlib. We'll see how far we get. As I already mentioned, I think yesterday or today, a lot of plotting in Python, regardless of whether it's Plot9 or Pandas' own .plot command, a lot of it is actually using matplotlib sort of under the hood. So we're building on top of matplotlib. So matplotlib is the final plotting lesson. And actually, it's kind of like it allows you a bit more manual control. It's a bit more low level. So actually, Plot9 is quite nice because the way it's designed in the interface is very closely allied with the usage of data frames. So it's a very nice package to use if you're already using data frames, Pandas and data frames, because it's very clued into efficiently just plotting what you might like to indicate from the structure of a data frame, from the labeled Pandas series and columns in a data frame. So there was an instruction in the setup to install plot9 using the conda install command. So what you should try doing import plot9 as p9, and if that doesn't work, if it says package not found, then you know that you will need to go back to the setup and look at the instructions here about installing plot9. I'll put that in the chat. Guess that's useful. So you do that one time, not every time you rerun your IPython session. Put in the Etherpad as well. So it's worth just checking that and making sure that you can plot plot9, and if there's no issue with that. Okay. So yeah, so let's do this so that we have a version of our surveys data frame without any nans in there, and then we can start to plot with plot9. So the basic so start off with what this at the moment just produces an empty plot. So I will again need to do plot.show, and similarly, if you're using IPython in the terminal, you may need to do plot.show. What you should see is actually just an empty plot, so it's not very useful, but this is the basic syntax that, as this describes, binds the plot to the data frame that we care about. The next step is we actually want to plot something. So it's so closely allied to the underlying data frame in the following way. So, for example, to plot two of the variables that we have labels for in our data frame, namely weight versus hind foot length, all it takes is this. You specify your the underlying data, which is the survey's complete data frame, and you specify a mapping from the data to the visualization, essentially, and you define so the AES for aesthetics class. That is where you define several things, including first and foremost what you're plotting. So clearly, X values, which X and Y values you're plotting if you're going to plot 2D scatter graph, for example. So we can do that. Let's see if that works. Yes, no, as expected that. So what you should see if you simply do that is still no data. At least there's X and Y labels, but it says still no specific data plotted because you have to define what kind of geometry, basically saying how to plot. So you've defined in your mapping of data to visualization, you've defined what you want to plot, what data you want to plot, X versus Y, but you've not defined how. So the interface is as follows. So in this definition of this plot, you add a specification of the geometry. So these geometry options, and there are various. So for example, we can see help p9.geom, I think might work. Yes, that won't work because it's still busy rendering my plot. Okay. If I double tap, you can see everything there. Let's see if we can find more help on p9.as maybe. Yeah, so that will show us. That just gives us specific examples. Okay, well, let's try. I mean, there's documentation online as well, obviously, that you can find, and I think there's links here to the plot9 package. Yeah, so there's documentation there on the website for plot9. But let's try specifying the simplest point style, say, or geometry for plotting this. So we have our go back to mapping, and you don't need to have this on. You can all have this on the same line if you like. I don't know why they've chosen this. Maybe it's conventional to show it this way, to plot it this way. But so if you additionally define your point geometry for mapping, for plotting the data, that should generate this plot. So I'll do a little poll to ask to plot. Okay. Okay, so we usually just take stock to see how everyone's getting along. If you managed to get this plot up, you can say yes in the poll. If you have any issues, any error messages, just say. Apparently, it's possible to get lots of deprecation warnings. There's something in the beginning here which says if you're getting lots of let's see. Oh, maybe that's just in the instructor version. Anyway, if you've got that, then why don't you try doing this first challenge? So using that same data set, so we want to create a bar plot that will count the number of records for each plot ID, so for each site. It suggests checking documentation, for example, a link here, or using within Python itself for the bar geometry. And when it says bar geometry, that would be in contrast to point geometry. So I expect the point geometry is the syntax is geom underscore point. So the equivalent for bar would be, imagine, geom underscore bar. So I'll tell you what I first thought to do for this, which was wrong, but perhaps it's wrong in a way that is potentially interesting. I don't know if it's interesting, but I thought it was shows how maybe thinking about plotting data the way that we've been doing with Pandas so far compared to using plot9. And your mileage may vary, and you may vary, and you may not have had the same instinct. But when I thought about what this challenge is asking, which is that what we want to plot is for each plot ID, we want to basically plot the count of the number of records for each plot. So thinking along the lines of how we've been plotting stuff so far in Pandas, I thought to myself, okay, what we want is we basically want to define, say, we want to somehow group the underlying data. I thought, okay, clearly we have to feed plot9 the right data. So we're going to start with our surveys complete data frame. Then we're going to group that according to plot ID, and then we're going to maybe count the number of records, and that will give us what? It'll give us. Oh, I need to close my figure before it will execute. what I've just asked it. What would that give us? Well, give us something that looks like the kind of thing that this is asking us to plot, right? For each plot ID, it's a count of the number of records that corresponds to. And then I figured, okay, right, fine. So now let's look at the plot9 syntax. Let's think that then probably what we need to do is something along the lines of this, saying that now the data we're asking it to plot is no longer the original data frame, but it's this new data series, in fact, called plot counts, with a mapping where we specify as X the plot ID and as Y maybe the record ID, because that's what this is still called. And then as a style, we're going to ask it to plot bars instead of points. So p9.geom underscore bar, which exists. So let's see what happens when we try that. No, that's completely misguided. So it doesn't like that because it expects a data frame or a mapping. So this tells you something about the way that plot9 works. So we'll have a look. We can have a look at the answer, and it's surprisingly simple. Possibly, if you're used, perhaps this is just me betraying the fact that I'm not used to ggplot or R, which is, so it might be no surprise to those of you who are very familiar with that. But so all that's needed to actually generate this bar plot here is simply to say we're using the same data. We're using the original data, the data cleaned up data frame. Survey is complete. In our mapping, we're not specifying. We're not even bothering to specify Y. We're just specifying X. We're saying X is a plot ID. Just plot the plot ID and figure it out. Figure the rest of it out, and that works. So is that unexpected? Even though we haven't even told plot9 what to plot? Maybe not. So it's kind of interesting. I started thinking, okay, how does that work? So if you check the documentation for p9.geom underscore bar, then let's see, what is a plot? Okay, so X and Y. All right, okay. So how is it basically? So clearly, what it's doing is it's plotting, somehow defaulting without us telling it. It's defaulting to plotting the number of occurrences of the plot ID. So it's doing a count essentially without us having explicitly done a count, which I tried to do, but that didn't want a Pandas series to use that as a basis. It's actually doing a count. So this there's something here which I think reveals that, explains why that is the default. So if you go through the documentation for plot9, there's probably some explanation about why and how it does this. But if you just come to this fresh, it's not necessarily obvious that will work. But there's something about the way that it's how the defaults are set up. It's so closely allied to Panda, to the use of data frames, and what people typically do is that it will take your original data frame, and for those X values, by default, it will do a count of the number of occurrences, which is great. I mean, it's really, really streamlined and quick. So it's nice that it works. I'm curious if anybody was surprised by that, or if this is completely, if you're familiar with R and ggplot, this is completely expected. But so feel free to comment in the chat if you like. So I think we have we have a break scheduled just for now. Let me check if that's right. Yep, just a 15-minute break. So we'll meet back at 15:15 for the final 45-minute session. And we'll continue. Feel free to keep looking ahead. So we're basically going to improve that. Yeah, it's more like Instagram. So we're going to keep going. Feel free to look ahead. We'll see that it's actually, this might all be quite quick because it's so easy to use. So it's very closely allied to data frames. But yeah, Okay, so we meet back here at 1:15. Oh, so I just see people just come back to the chat and see that people have had some issues. Cannot import name multi-type sort from mizani.utils. Not a clue what that could be due to. So Peter, you updated everything and it seemed to work in the end. Okay, that sounds like the thing to do. When you say you updated everything, what do you mean?
I updated. I think it was everything, but there was a command line. There was some text somewhere to do the update in the warning. It told you to run this to update. I think it updated Python version.
Right.
And then I reinstalled, and it just seemed to work eventually. But it did take a few goes.
Okay.
And it could be. I vaguely remember I tried a lot of different things, but I think that Mizani utils, I think I had to update that or reinstall that as well separately.
I see. And was this with an Anaconda install that you just installed recently?
Yeah. So Anaconda, I think I'd had it a long time on my laptop.
Okay. Yeah.
So I updated that.
But you updated that just now to get this working, or before the course?
It was before the course. I noticed it in the
Okay.
course text to install that, but I was getting that error quite a lot when I was trying.
Okay. Yeah. So one thing is that if it is the question is if it is indeed an error or a warning, because it's just a warning that's ignorable, then that's one thing. But if it's actually stopping you, Andrew, then yeah. And Thomas, I think what might work actually. So yeah, it might still work if you use the underlying matplotlib command, i.e. instead of p9.ggsave, which if that doesn't work, then possibly again the plt.save fig command that we were using before when we were plotting the pandas data, because that's also based on matplotlib, just like p9 in the end is plot9 in the end is based on matplotlib. In the final matplotlib episode, actually, you'll see that you can actually modify some of these plot9 plots using matplotlib commands. So my hope would be that the plot.save fig command also would hopefully work for plot9 plots. And Alba, is your link, is your question whether to send a link to how to install or how to launch Jupyter Notebooks?
Hi. No, I know how to. It's installed already and everything. Just I wanted to know how to do it without losing my history. But well, I did it anyway.
Okay. Without losing
it was the only way. Yeah.
Oh, okay.
Yeah.
Losing history
No,
of.
well, yeah. Well, what I could have done is open a new, like a new window, I guess, and launch it from there. Yeah, it's okay.
Yeah, so in the browser you can, it is like localhost :800 or 880, and then visit the same URL to see your interface, and then maybe open a new notebook.
Yeah.
Something like that.
I didn't remember if it was like always the same local host or not.
Yeah, so you can have more than one. So basically, when you launch Jupyter Notebook, it sets up a little a server program that just runs actively and hosts the web interface that you visit in the browser, and you can have more than one server instance running at the same time. And then I guess what will happen is that they will probably just get different port addresses. I suspect. So one of them will be at localhost :800 or something, or 8000. The other one will be at some other port number. I suspect. I'm not entirely sure. But
Thanks.
yeah, no worries. Andrew, did you have any? I don't know if you're around now. If you had any luck trying to get plot9 to import.
Not at the moment, no. I'm trying to uninstall it at the moment. going to install a slightly earlier version to see if that'll force Conda to update any libraries it needs to update.
Wow. Okay. Had you installed with the conda command, just like in the, or had you done it with pip or with conda? With conda, okay.
No, with Conda.
So all people, different setups, getting different. I mean, that's not that odd if your starting point is potentially different. But yeah. Thomas, any luck with saving your figure using the plot.savefig? Okay, I guess Thomas probably just momentarily dropped out. Yeah, so unfortunately some people are having issues with actually doing the plot9 import. Yeah, I don't suspect that using a Jupyter notebook instead of doing it in terminal will make any difference, because it's just using the same, drawing upon the same installed packages. But yeah, hopefully he's talking through what you can do. I mean, if you get it working afterwards, then you can still go over this and then maybe try playing around with some things yourself. From my view, kind of this episode and the following after it with matplotlib is Tom was saying, okay, file saved. Okay. Yeah, you do have to, I guess, yeah, make sure to run the plot.savefig right after the actual plot command, just in case. I guess, yeah, lost. Thanks, Peter. Yes. Okay. Well, we'll just press ahead. What I was about to say with about this episode and next one, although it's like, well, we're finally getting to some visualization now, and in the sense it's exciting because you can actually see some stuff and it's super useful as well. But I feel like it was sort of warranted to spend quite a lot of time on some of the earlier stuff, because once you get to the plotting, in a sense, there's like conceptually, it's not necessarily. I mean, okay, so matplotlib is conceptually a little bit different in how it handles defining the data that you're plotting and defining how to plot it from how plot9 does it. But I thought, I think some of the most sort of for people who I thought might be signing up to do this course with no or little background, as the description of background says for the course, it kind of made sense to spend quite a lot of time on some of the basics Python stuff and lists and dicts and tuples and indexing and data frames and how to deal with those. And once you've got the data frame once you've got the right data in the data frame, knowing, well, we looked at quite a few ways of plotting directly using Pandas. And then as it seems now, once you get the data frame, once you get the right data in the data frame, using plot9 can actually be supremely simple. So in that sense, maybe it's just getting to grips with details about how to tweak your particular preferred way of plotting something with either plot9 or matplotlib once you have all the data in the right place. But from my perspective anyway, that conceptually doesn't add, although it's good to get practice, that conceptually doesn't add maybe as much, or this requires more digging in the manual and figuring out, how do I make my plot a slightly different color, or how do I change the geometry, the point size. So I think hopefully you agree that's justified that we spent quite a lot of time on getting to this point where we now have the data in place to plot stuff. So let's have a look now through some of the things you can do with plot9. Thanks, Catherine. So yeah, it's as we saw in the example. So this is saying that one of the options in plot9 you can add in your definition of the geometry is to add this alpha option, which basically is transparency, which basically makes it a little bit clearer to show overlaid points. So you can add color as well. So simply continuing with the same weight versus hind foot length plot, adding a color specification, so blah 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 in a sense. Then you can do something nice, which is in the mapping of not now as an option in the geometry specification, but as an option in the mapping. So conceptually, in how you map the data onto the visualization, you can specify how you basically categorize the color based on the value of species ID, and it's clear that so we know the species ID is a two-letter basically two-letter code, but it appears to be that without any further sort of instruction about how to parse these two-letter codes, Plot9 is happy to just examine the, I guess, range of different values that occur for species ID, and then to decide that this how to make a mapping from an element of that discrete set into an element into a color within a discrete set of colors, like a color map. So it does some kind of default choice, which you can always tweak, I'm sure, with purely just a simple specification by linking the data frame, a given data frame ID, as the value which the color depends on. So it's really nice, it's really high level and it's really, really simple. So yes, you can add labels as you would expect to the x-axis or to other axes. You can do things like, what are we doing here? A theme that changes the background. Okay, fine, fair enough. So there's lots of things you can do. This one is suggesting that you also map, so you can build on this by mapping the sex variable to the color fill of the bar. Oh, no, not this plot, sorry, going back to the bar chart essentially. So this one here, and then adapting this plot to reflect the sex within this, further subdivide the count for each plot ID into the sex. So can we do, so how can we do that? Let's just have a look. And just in the way in which we specified the color as being mapped onto the species ID for this scatter plot, seems clear that we can ask for the fill of a bar plot to be mapped onto this other data frame field. And again, Plot9 is happy to do the mapping onto discrete set of colors based on the two values it encounters as possible values of sex. And yeah, it's worth, and I was going to say it's worth noting how it deals with NANDs, but of course, we don't know actually how Plot9 would deal with NANDs if we would just ignore them or if we would explicitly map that onto a third category, because we have in our surveys complete. The reason why we call it complete is actually because we did a drop NA. We dropped all NANDs from that data frame. So this data frame doesn't contain any NANDs, so we don't actually know how it would handle that. And then in addition to this mapping, it's actually a manual specification of the particular colors that you would like the fill to map onto. So if you don't choose that, it might be some other defaults that get chosen. Okay, so we've had scatter plots, bar plots. So we can also plot distributions, which is nice. So we can apparently use a box plot. So whilst retaining the same mapping specification of what data we want to plot as X and Y in terms of their data frame fields, we can now change the geometry from a point or a bar to a box plot. And that shows us the mean, median, percentile, outliers, etc. for the different species IDs. We can add on top of that, modifying it further, as well as the box plot. We can add the jitter geometry, and jitter geometry is basically adding back the original, or adding the points of the data, but in such a way that they're kind of so jitter referring to a little bit of jitter, a little bit of shuffling back and forth. So essentially within each species ID sort of box region, making sure that you don't plot all the points on the exact same value on the x-axis, the same point in the x-axis, in which case you would just see a line and it'd be so difficult to tell the actual distribution of the points. So they're just jittered a bit or scattered a bit and offset according to some rule of thumb, some heuristic within that box plot, so that within that range of the x-axis that corresponds to that species ID, so that you get a better sense visually of the actual data from which those box plots were derived. And additionally, you can specify some transparency purely for that jitter as well. And the box plots themselves are now made very completely transparent in order to make that jitter more visible. And you see only the vaguest outlines of those box plots, depending on the background. Okay. So additional options, you can try a violin plot, which shows you the actual shape of the probability density function or approximation of the probability density function, and using a different scale. Time series. There's a question about time series. I think it was Andrew was asking potentially. There's not much actually handling of date time format really involved in this, I think. But the suggestion here is that you look at simply time, a time index as a time series in that sense. So not like a date time 64 format, Pandas format date time, but yeah, purely the integer year as your x value essentially. So what we're going to do there is we do actually modify the underlying data frame. So suppose you want to get the count per year for each species. So we are going to do grouping there. So you can't. So here you cannot just simply present the original data frame and ask it to give counts, because you want to do some. You need to do a grouping according to year essentially. Yeah. In what you present to plot 9. So it doesn't. Yeah. So what we're going to do, we're going to group by year and by species, because we want the number of data points for each species. We can now do counts by selecting our species ID rather than, so far whenever we were doing counts, we were selecting the record ID because we knew that the record ID would always be not a nan, i.e. would be a valid value. But now in this data frame, survey is complete since we dropped all the nans. We know that we can, in principle, use any of the fields, any of the columns to count over, since they all have, none of them have nans, so the value will be the same regardless. So this extracting the species ID is just one option, since it is all we care about, but it doesn't really matter. We're just counting the number of data points, number of rows for that group data, group by year and species ID. There's a, yeah, if you were to actually plot this, you would see that, let's see, let me just check if it's worth looking at this. Just checking to see if it's worth actually showing this as a demonstration, or whether it's simply something to look at afterwards that's maybe worthwhile. Well, we can have a quick look actually. Let's see if we'll come up with something similar. So in terms of plotting the time series data, so let's see what they call it here. Yearly counts. Okay, so if we do this, if we group our surveys data frame according to year and species ID, and we count according to the species ID, what do we get? Then we get for all the years, it's just shown 2 of the years, but these triple dots, we've got the intervening years in between there. For each year, for each species ID, we've got a count of how many there are for each species. Okay, and then if at this point, so what is that type? That's a Pandas series. But yes, that's the thing. So you would say, okay, fine. So can we ask plot9 to plot this? Well, no, we already saw earlier when I was trying to do it with the my my overly complicated attempt, you already saw that Plot9 complained when you gave it something that wasn't the Pandas data frame. So actually what we want to do is we want to change this Pandas series into Pandas data frame. And one way to do that is to do what they're doing here. And this is in fact why they do it. They reset the index, and then they rename this. And so this changes the Pandas series into Pandas data frame with an index, because you know this Pandas series, it has named a named first column year, and then a named second column species ID, but it doesn't have an unnamed index. So you're creating a data frame out of that, and that is then what you can give to Plot9. So we give it that yearly count data consisting of the column for the year, column for the species ID, and the counts, and then we ask it to map X for each year, map the number of counts, and that means that there is what we haven't specified. So that means that we will get for each combination for each year, we will have however many species IDs there are for that year being plotted. In other words, we expect to see say a time series. We expect it to plot a time series for each year. Sorry, a time series for each species ID. So let's see how that looks. Okay, so I'm missing something. Bad type argument here. Okay. Yes, that's because although I have reset the index, I've not actually kept that. So now that I've actually kept the data frame version of yearly counts, I should be able to plot that. Okay, so as it stands, that doesn't work very well because this now hasn't separated out the there's no separation in the time series for the different species IDs. They're all run together. So as it says here. So how do we fix that? Well, we need to add an additional specification where we distinguish the mapping. In particular, we can do it according to color, for example, and we distinguish the mapping based on what the value of the species ID is. So we can add in there something that separates out the data in basically separates in our mapping, introduces an additional separation that will be output as a different color, and that works. So that allows us to generate distinct lines for each species ID. So time series for different species IDs, as shown here as well. Okay. So faceting is a useful feature of Plot9. Basically allows you to produce multiple plots for different fields that are found for variables. So for that you've not plotted, which you've not explicitly plotted. So facets being like facets of a diamond, windows, perspectives. So in other words, for the same data that you're plotting, plot how that looks for different contingent on selection of subset of the data for specific values of another variable. So for example, if you use the same scatter plot definition as we used back up a bit to plot the distribution of hind foot length versus weight, and if you then, so we'd already introduced, see the color for species ID, we'd already introduced, so we'd already separated out the different species based on their color. And if you then ask it to do a, what Plot9 calls a facet wrap, so basically generate different facets, generate multiple plots based on the following data frame field sex, then it'll introduce it will generate 2 plots of the thing that you were already plotting before, each with a subset of the data corresponding to a value for, in this case, either F or M for the sex field. So it allows you to split up whatever you're plotting based on contingent on the different existing values of a given other variable. So if you split things up according to plot ID, that will give you an oversight into the distribution of species IDs. I'm sorry, a distribution of the length, hindfoot length versus for different hindfoot length versus weight for different species, looking at geographically different plots. So at a glance, it allows you to get a lot of insight into the features of your data. So that's quite nice. There's just further options here where you can specify some conditionals there or some combinations. You can create a 2-dimensional grid, essentially, where you're along the y-axis of your multiple plots, you're faceting over sex, and over the y-axis you might be faceting over years. So you get different combinations of variables, of contingent variables in which, sorry, I'm probably not using the word contingent in a statistically sound sense, but yeah, so the other variables which are present in your data frame. So yes, something you could try out with faceting there, various things to try out, various things to customize, and these are, in my mind, are just basically tweaks and variations that are endless, and you should certainly explore these when you're producing your own plots for publication or otherwise, to see what you can get out. Things like changing the thickness, all kinds of stuff. So this is a quick whirlwind tour of Plot9, and apologies. So I thank you for Andrew for trying to suggest how to regress or progress the version of that module of Mizani installed. If you don't get it working, Peter, at some point I suggest, well, this is a horrible suggestion, but the whole turn it off and on again can be extended to nuking, completely obliterating your install and installing again from scratch. That's one of the reasons why, even though people say Pandas and pip and various package managers are you supposed to solve all these compatibility issues, that you exactly don't run into issues like this, because Conda is supposed to only upgrade and downgrade to maintain compatibility, and you should never run into issues like this. It's almost impossible. So the Python is often sort of marketed as saying Python's great because there's a whole ecosystem of packages that you can use, and there's a whole zoo of packages, which is great because there's lots of functionality, but also it's an absolute version control nightmare, a versioning nightmare, as you've just seen demonstrated. So the intercompatibility of different versions of packages with each other can be an absolute nightmare. But again, it's why, from the perspective of publication and reproducibility, it's important. When I think we discussed this yesterday, I think as well, even when you're, when publications are more and more asking for example, what software you ran and what versions of software you ran in order to generate, in order to process your data, analyze your data, create visualizations. That includes also, the versions of packaging. So if you were to specify how you processed and visualized your data in Python, that might include a listing of the Python environment, which would include could potentially include a long list of specific numerical versions of all the packages involved. At the very least, the versions of Python itself, version of NumPy, version of Pandas, version of Plot9, clearly, and whatever else you're using directly that's relevant. Aha, great. So you can now plot the data. Okay. At least you can plot the data even though you get a warning for SciPy. Right, that's great. Okay, we have a little bit of time left, about 20 minutes left, not much time, but we can have a look at, so this is the, so you can save, you're supposed to be able to save a plot like that once you've generated it. If you assign that, the syntax we can use to plot to the right-hand side for a variable assignment, then if you do .save on that variable, you should be able to, in principle, save it. Thomas, I don't know if that will work for you. So with that, we come for the last 19 minutes of the course to as I said, I wasn't going to go on. I wasn't going to planning on doing the SQL session anyway, which hopefully, I mean, I hope that doesn't disappoint anyone. But hopefully, you can look at that afterwards. And if there's any questions, feel free to get in touch. I'll try to help, even though I'm not familiar with SQL. I can help on the Python side. This final session on matplotlib. So matplotlib is important, and it's kind of ubiquitous, not just because lots of people use it directly to plot, but also because, as I've already said a few times, it's actually what it's what a lot of other visualization packages for Python are built on top of, like the way that Pandas does visualization. The Plot9 also uses matplotlib. So the examples are you can work through these examples, but just to show as an example, if we want to do something similar to what we're doing just now with Plot9 and plot the hind foot length versus weight, you can do it as follows. And I think this will be without having dropped the nans. So I think it by default it just ignores the nans. Matplotlib can be overwhelming. Yes, yeah, this is what it suggests. So one strategy is that you can start creating a plot in Pandas or Plot9, and then you could use matplotlib to actually modify things afterwards. I'm not sure that's always the best approach, but I mean, a lot of people like to use matplotlib straight away. But I think it all depends on your use and what you're happy with. Clearly, Plot9 is very tightly integrated with data frames, Pandas data frames, so it does seem like a very convenient way of plotting data frames. So it's certainly useful. But matplotlib can be used very directly with outputs that you get from NumPy, SciPy. So these NumPy arrays, we've not talked that much about NumPy arrays, really. I've mentioned that they are the default basic container in Python for storing numerical format data. Even some of the Pandas series are built on top of NumPy arrays. I think they're basically NumPy arrays with some additional metadata, essentially, like the record name, the field names, and all that kind of stuff. So what you can do is NumPy has a lot of numerical functions for generating, manipulating arrays, multi-dimensional arrays, and also, for example, so you can generate a one-dimensional array with random numbers sampled from the normal distribution, and then you can plot a histogram using the matplotlib.hist function. So matplotlib, can so in the same way that so it's kind of like low level in the sense that whereas Plot9 and the Pandas plot directly sort of accept and work with the Pandas series, matplotlib very directly works with underlying NumPy arrays. So it's all like a little bit one level sort of lower down, a bit more raw, a bit sort of closer to the underlying data. Even NumPy arrays are under the hood, or C arrays, because actually the Python interpreter itself is written in C. So there's anyway, so going on under the hood. So you can create subplots, and it can get quite. So you have a lot of control with matplotlib, but it does take more boilerplate and more figuring out how to do stuff. So it's nice to have something like Pandas plotting or Plot9 to quickly do some fairly complex plots that would take a lot more effort to do with matplotlib. So there's an example here which might be useful, which is how to actually do the kind of passing on of the torch from Pandas plot or Plot9 to matplotlib. So for example, if you let's see, the idea being here, you start with Plot9, say, and you generate a plot that the scatter plot that we started with. Then what you can do apparently is you can, on that Plot9 plot, you can say .draw, and that output something that that matplotlib can further deal with. So then this is, so let's actually do that. I'll do it with the service complete, which we were using. And if I say my plot version is now my plot.draw, then what kind of thing is my plot version, it's a matplotlib figure. So that's the translation step, because my plot was a plot9 ggplot. We've called the dot draw function on it, and maybe there's some additional help there. Oh, that's literally just written out, drawn, I think. So it's also shown the help. So renders the complete plot, returns a matplotlib figure. So it's fairly straightforward. But it's that step at which you have the translation from plot9 figure to the matplotlib figure. From there on, you can use matplotlib syntax to manipulate and set things that perhaps you would like to control, but wasn't quite possible to control within plot9. So you have a lot of control about the fine details now. So there's an exercise here, which is quite a bit more protracted exercise, which is there's some stream gauge data set in the data directory. And what was suggested you can do as an exercise is to work with Pandas to, essentially process the data, analyze the data, start to plot it using Pandas, and then generate convert to matplotlib, and then use matplotlib to further manipulate that. So you kind of see the outline of that approach here. So hopefully, matplotlib is a whole thing on its own, and it's got its own. It's in the end, it comes down to just syntax for how to define plots and how to define visualization, like thicknesses of lines, and each plotting package has its own syntax for that. Conceptually, it's not too complicated, or it's just a bit of hassle sometimes. So I think it's quite a nice thing to suggest, starting off with something like Pandas plot or plot9, and then if you need to, transferring it to a matplotlib figure and diving in further. Okay, there's a final thing to explore as well as a suggestion. But I think that this is probably a good point at which to kind of wrap up. We're even slightly before 3 o'clock, but that's fine. I don't think it's worth diving into anything more. So the only thing that's left that we didn't talk about at all is this, as I said, this final session on accessing SQL databases. So you basically import, as with everything you're trying to do with Python, you import some relevant package, and you create a connection as follows, and then you start to issue queries. I don't think there's a. Oh yes, there's a connection here about how to load the data that you fetch with SQL queries into a data frame. So you can read from. So let's see. Here we go. So Pandas clearly provides a facility not just to read CSV files, but also to read SQL query from a connection. So you use SQLite 3 package in combination with Pandas to connect them together so that you can ingest data from the SQL database into data frame and do whatever you're wanting to do, and what we looked at yesterday and today, how to manipulate. And then ultimately you can also then, instead of writing to a CSV file, you can write back to the SQL database with a to SQL command and then close the connection. That's it. That's that's a lesson. So that's good to know that that's possible. But hopefully, with all the background that you've got from today and yesterday, that will hopefully be fairly straightforward. So the idea to remember with Python is that everything's an object. Just try to, if something's not working the way you expect it to, check that your assumption about what your object is in terms of its type, whether that's correct or not, by using the type command. If you have alternative formulations for how you can work stuff out, it might be worth using the time it command in IPython or Jupyter Notebook to see how much time it takes if it's something that you're going to do a lot. If you're making if you're doing something more than n times, where n depends on how much effort it is to automate versus how much time it costs to do it manually, then automate it by defining capturing what you're doing in a script, defining it as a Python function, and then calling that. So we haven't talked about I've been doing stuff from, I've been showing stuff from the terminal and also from Jupyter Notebook briefly. What we haven't shown is, let's see, what's it called? An IDE like Spider, which is just one integrated development environment that you could potentially use. It's included in Icona install. I'm sure you can, there's various ways in which you can install it. I'm just loading it to show you. So that might be useful because, yes. Okay, let me see why this is working or not. Okay. Interesting. Okay, anyway, this is launched. So this is Spider, the integrated development environment. And it's useful because what you can essentially do is you've got an IPython console here, so you can prototype stuff, just check the stuff work, blah 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 blah, do all your working out here, and then here you've got your Python script which you're writing. And so that's quite typical and quite nice actually, because typically that's I would say what you would do. You're kind of interactively trying out stuff and obviously failing and then correcting and then failing and tweaking. And as you gradually make things work, then you would build it up there. So I'll just show an example of that. So just for example, so this is would be some Python script that I've created to essentially analyze application performance profiling data. So the result of trying stuff out a lot interactively and then gradually concretizing things. And there's a lot of duplicated code here, so it's probably worthwhile at some point making that into, well, I say a lot, but there's some duplicated matplotlib code. So essentially importing a bunch of packages which ultimately turn out to need to be needed, defining some functions that do things that I want to do a lot to when I read CSV import files, and then do some conversions or processing, for example, ignoring when inputs are obey certain criteria, tolerances, parsing and then modifying things and calling those functions. Basically, the idea: make everything more repeatable, easier to understand, easier to use, easier to modify, easier for somebody else, including your future self, to understand. Yeah, the variable explorer. Do you want to point out where that is, Andrew? Because I've never used a Spider before. How do I find the variable?
Okay, on top right panel, you've got 3 tabs at the bottom. Variable explorer.
Yeah.
And if in the IPython console, if you type in a variable, say create a list, x equals 1 2, a list 1 2 3 4.
Yeah.
And then if you double click on the X variable, it brings up a nice table.
Yeah.
And that's what I use for exploring data frames. Sometimes data frames, you get an error and it's not quite clear from the Panda error message what's causing it. And I often use that to try and figure out what's in the data frame.
Yeah.
Just so I'm clear, you'd use this instead of Jupyter Labs. So this is like where you'd write your code, run your code, see your outputs, and explore your data.
Yes, I find the Jupyter Notebook is not very useful for software development. It's okay for demonstrations and showing people what to do, and it's highly interactive. But when you're trying to solve a software bug, then I find Spider or something similar. I think the Windows version is Visual Studio, although I haven't used that for years. But being able to step through the code, because this environment will also allow you to step into functions and step through those functions to find out where your bug is, basically.
Mm-hmm. Very nice. I would agree. That makes a lot of sense. So yeah, so the data frame, I've just loaded in the data frame that we've been looking at, and as you can see, it's nice. It is nice because it allows you to, yeah, it's nice. What did GUI get you?
My whole PhD using this.
So this is hopefully not triggering. Right.
It's great for sort of developing code on the fly, so to speak.
Yeah. Yeah.
Because quite often you don't always have you don't always realize that you just want to do something quickly.
Yeah.
And then you find yourself repeating those sort of tasks. And eventually you start then developing software, and that then allows you to identify what parts of the code you're repeating, and then you can abstract it into a function and build your software up as you go along.
Yep, that's it. So people may or may not be familiar with this comic, which I think is always nice to show when we're talking about software development. Basically, yeah, think about how much time you would save if you were to automate the thing, and it's not just about time saving, right? Because the more you automate, the more you are likely to at least reproduce the same error, so that at least your errors are deterministic, which makes them easier to work out when they're happening, easier to fix, and easier not to replicate.
That's an interesting graphic. I've not seen that, because
yeah.
there is this balance between doing software development versus actually getting the job done. And you have to, you have to sort of decide, how often am I going to reuse this bit of software?
Yes. Well, the interesting thing is that so making things more essentially for reproducibility, documenting your workflow in the form of an automated Python script should be useful not just for yourself, but also for others in your group or might take on the work. But yeah, the fact that in fact journals are maybe more and more emphasizing the providing information like that about the software environment and about maybe the workflow scripts, and are increasingly flexible for hosting these things and for allowing you to retrospectively update different versions of the software and scripts, is good, because it means that it becomes more easier to check, easier to try and replicate. And it means that the incentive is more balanced in terms of it's not going to, it's a positive thing. In some cases you have to, so you don't have a choice, so you might as well. So that promotes kind of doing it anyway. Less for cost, or if everybody's bearing the cost, you're equally, that's the market situation, that everybody has to kind of do it. So you're all slowed down in terms of getting your publications ready equally by an equal amount. So yeah, so I was gonna, that's pretty much I think all that I wanted to present. If there's any questions that occur, feel free to ask, and if you want to get in touch afterwards, it's fine as well. I think you have my email from one of the training email addresses. I'll put it in
okay, chat. Thanks very much.
Thanks, Andrew, for your help with the virtual box and everything as well, the queries. And so, yeah, so I hope this was useful for people. As I said, I think teaching you to fish, rather than remembering all the exact details, getting a useful workable approach for how to find the docs, how to find the help, how to figure stuff out yourself is more useful than trying to remember all the exact details. Okay, thanks everyone for sticking with it. Those of you who are still there for both days. And yeah, all the best, and I hope this turns out to be useful in some way at some point. Oh, the course material is absolutely shareable, because in fact, the only reason this is not something that we produced in terms of the ARCHER2 team. This course material here, if that's what you're referring to, it's hosted by the Data Carpentry website. So there are some, whatever restrictions there are, it's already completely public. So whatever restrictions there are in terms of the licensing, there's some licensing here about use, but in terms of sharing, I mean, I think it's created to share, as widely as possible. So yeah, just have a look at the website here. It's the Data Carpentry website. Yeah, great. Share it. Share the in case it's useful as far as wide as possible. That's why it was created, because I wanted to help people. Yeah, the recording will be online. So Claire from our team, she was processing, I think, yesterday's recording, which may or may not be online. So let me just check the. We often link it from. We should be linked from the ARCHER2 YouTube channel, or from the ARCHER2 website, and also from the ARCHER2 YouTube channel. So let's see. Yeah, the ARCHER2 HPC YouTube channel has. Oh, yesterday's session is. No, day 2, session 1. This morning's session, she's already put up even. Wow. Okay. So yeah, it will all be there. Yeah. Of course, it's it'll be a lot of scrolling through blah 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 to find a bit you're interested in, because these are long long recordings. But I guess if you know exactly what you're after, you can find it. And I hope you managed to get the plotting working finally in the end. What blank plots? Blank plots. So some of the plots are blank, right? Some of the initial blank 9 plots are blank. But if it doesn't give an error when you plot and just gives a blank plot, that at the very least is a good starting point. Because that means at least the package is working, probably. But if it's blank when it's not meant to be blank, yeah, then that's a different issue. I guess, yeah, just try either from scratch with the materials or with some very basic Plot9 or Matplotlib example from the Plot9 website, or because I think the Plot9 package includes some data that you can load directly from. Oh yeah, here, for example, it says from plot9.data import MT cars, so you can just import some data. And these examples should just work if your installation is functional. And at some point, you may want to just sort of obliterate your Python installation and start from scratch with whatever approach you think is best. But yeah, should hopefully work. Spider, I think, well, that depends, right? Because you didn't install the Anaconda install. I know it's included in part of the Anaconda, the main Anaconda install. Otherwise, I guess you just have to. Okay. Yes, that'll be it. But you can download the Spider IDE independently. You can probably even, let's see. Yeah, oh, okay, using Conda, for example, as well. There'll be more than one way to get it. macOS or for other. Yeah, there's a standalone installer on Windows as well, if installing it with Conda is problematic. So when you visit this website, you'll get the option to download for Windows OS. Or here they are. I guess .exe will be the Windows installer. Oh, here we go. Yeah. So that's another way to do it. All right. Okay, so I'm going to leave it there. So nice to have met you, and all the best.